How's it going, everybody? I'm going to be talking about section 5.1 in this video. Biggest thing you need to know is you need to memorize everything that you see right now. So screen capture it, do whatever you got to do, make note cards, lots and lots of note cards, and memorize all of it. I'm going to show you some shortcuts how to memorize Pythagorean identities and how to remember cofunction identities. You should already know that tangent is sine over cosine and cotangent is cosine over sine. These are also by the same thing. Cosecant, the reciprocal, is 1 over sine. Secant, 1 over cosine. Cotangent, 1 over tangent. Notice they all go together. Even odds, this is talking about your symmetries. Notice with cosine, if you have cosine of a negative angle, it's just cosine of that angle, or secant, same thing. Here, notice you have negatives on the outside. Cool. Now I'm going to show you guys those shortcuts I was talking about. Alright, so I'm going to teach you guys the trick for the Pythagorean identities right now. You knew that a unit circle is x squared plus y squared equals 1. Well, if x is the cosine, then this is cosine squared plus y was sine, so sine squared equals 1. Cool, my Pythagorean identity. So if you want to create the other identities from this one, the other two Pythagorean identities that you have, if you start out with cosine squared, just a sec. Okay, if you start out with these functions and divide everything by sine squared, oops, and divided by sine squared, and divide the other one by cosine squared, and you will produce the other function. Oh yeah, I forgot about my fancy pen. Thank you, Zoe. I appreciate my fancy pen. I put the monkey on it. So then cosine divided by sine is cotangent. Oh, can you read the gold? Yeah, you can see the gold. Plus sine squared divided by sine squared is 1 equals 1 over sine squared, which is cosecant squared. Yay! And then cosine divided by cosine squared is 1. Oh, come on, Pinky. Sine squared divided by cosine squared is tangent squared. And then secant squared. Yay! Oh, there it goes. Yay! Here's another way you can remember Pythagorean identity. Yay!
I'm gonna see if I can finish this off really quickly, and then I'll play it.
You're in the video now, Zalman. Okay, so the way you use this to memorize the Pythagorean identities is you have sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. 1 plus cotangent squared equals cosecant squared. Hey up. Also, notice all of the functions with c's are on the right-hand side. However you want to memorize these Pythagorean identities, whatever you do, just do it. Do it, brah.
I mean, it was eventually going to come out.
Alright, here's how you memorize the cofunction identities. So notice, sine of pi over 2 minus theta is cosine. Whoa, co. Cosine of pi over 2 minus theta is sine. Whoa! You took away the co. Bye, Allie. Have a good night. Secant of pi over 2. No, there's no discreteness. Secant of pi over 2 minus theta is cosecant. Oh, there should be an equal sign there. What are you doing? Okay. Co. Tangent of pi over 2 minus theta is cotangent. Cotangent of pi over 2 minus theta is tangent. Cosecant of pi over 2 minus theta is secant. Yay. Cofunction identities. Alright, so the first example we're going to look at is something like this, where it gives you a cosine function, it gives you a sine function, is asking for tangent. So this is something that you had before. You can say cosine is adjacent over hypotenuse, so there's our angle x. Adjacent over hypotenuse, sine is opposite over hypotenuse, yay. So there's my triangle. To find tangent, I know that's opposite over adjacent, so 2 root 6 over 1, which is just 2 root 6. Okay, and doing an example like this, again, same sort of thing, but this one, notice this one says sine is positive and tangent is negative. So we have all students take calculus. Tangent is negative in the second and the fourth quadrant. Sine is positive in the second and first quadrant. The only place that both of these are true is the second quadrant. So if I draw my angle in the second quadrant, there's my reference angle, Sine is opposite over hypotenuse. By Pythagorean theorem, I can find out that this is square root 8. Since it goes to the left, it is negative square root 8. And then cotangent of your angle is adjacent over opposite, so negative root 8 over 1. And then secant, it's the opposite of cosine, so hypotenuse over adjacent, so 3 over root 8. Yep, have a good night, Kate. Bye. All right, so this is the part of the video where we are actually going to get into simplifying trig functions. You may need to watch this multiple times, 2, 3, 4, 5 times to actually understand what is going on. I'm going to be using all of my identities. Those are the identities that you are supposed to memorize. I'll pull this up every now and then, but you have to use these in order to simplify your identities, or simplify your expressions. So if I don't know exactly what to do, all I'm going to do is put everything I can in terms of sine and cosine. So I have my rule here. When in doubt, oops, not when in doubt, sine and cosine it out. Hey, he rhymes. Okay, so all that means is put everything in terms of sine and cosine. So tangent, I know, is sine over cosine. Oops, not that, not that, not that, not that, not that. Where'd it go? There it is. Let's move you over here. There he is. Yeah, so pretty. So tangent, do right there, do is sine over cosine. So I can say that this is sine theta over cosine theta. Cosecant is here. So I have 1 over sine, so times 1 over sine. Then, mathematically, mathematicos, fancy pen, fancy monkey pen. Sine divided by sine makes 1, so I'm left with 1 over cosine theta. 1 over cosine is secant theta by that identity right there. Cool, that's all there is to it. It's just going to be a lot of that, a lot of substitution and simplifying. Okay, looking at another one now. With this one, notice it's not theta, that is beta, I believe. It might be alpha, I don't remember, sorry. But all that means is just different angle. So again, I don't know what to do, so I'm just going to write everything in terms of sine and cosine. So by our identities, where do they go? I keep losing them. By our identities, secant is 1 over cosine, tangent is sine over cosine, right there. And then the other one I have is just sine, so I'm just going to leave it as sine. So I have 1 over cosine minus sine over cosine times sine, and I'll say over 1 so that I'm multiplying fractions. Okay, now I already have common denominators, so that's pretty cool. So I can say that this is going to be over the same denominator since I'm subtracting them. So I have over cosine, 1 minus sine times sine would be sine squared. Okay, well notice that's really close to your Pythagorean identity. Your Pythagorean identity is sine squared plus cosine squared equals 1. So if I move over that sine squared, if I subtract it to the other side, then I have cosine squared equals 1 minus sine squared. So hey-oh, if I know that 1 minus sine squared is equal to cosine squared, then I can substitute in cosine squared for where I see 1 minus sine squared and say this is equal to cosine squared over cosine. And then GOLD. Cosine divided by cosine makes 1. So I am just left with cosine angle. Happy day. Make sure you guys rewatch these. All right, looking at another one. Cosecant, secant minus cotangent. I'm going to move this up since you know the directions mean simplify. Cosecant I know is 1 over sine. So 1 over sine. Do not change your angle. 1 over cosine is secant minus cosine over sine. That is all coming from your identities. Come on, adjust. There we go. Beautiful. Beautiful. Okay, so then I need common denominators since I am subtracting fractions. Notice that you have fractions and you have to have common denominators when you add or subtract fractions. So this one will have a denominator of sine x cosine x. This one only has sine x, so I need to multiply this one by cosine x over cosine x. And then I will have 1 times 1 is 1, minus cosine times cosine is cosine squared x over sine x cosine x. Jeez, come on. There we go. Why are you messing up today? Come on, buddy. Pick it up. Okay, and then this looks like my Pythagorean identity. So cosine squared plus sine squared equals 1. If I subtract the cosine squared to the other side, this will be sine squared equals 1 minus cosine squared. So I know this is equal to sine squared on the top, so I have sine squared x over sine x cosine x. Sine divided by sine is 1, so I'm left with sine x over cosine x, which is just tangent of x. Happy day. Next. All right, with this one, I notice I have a cofunction identity right there. So that is cosine theta. So this is sine squared theta cosine theta minus cosine theta. Now notice, in both of these terms, I have a cosine theta. So I can factor it out such that this would be cosine theta equal or times sine squared theta minus 1, which I believe in this previous one over here. Oh no, we didn't do that yet. Okay, so again, it kind of looks like my Pythagorean identity. What color am I writing in? That's gold. I don't want gold. Luster pink. Oh, so pretty. Cosine squared plus sine squared is plus 1. Here I want to have sine squared minus 1. So in order to do that, I'm going to have to move this 1 to the other side over here. I'm going to have to move cosine squared to the opposite side as well. So if I do that, I will have sine squared minus 1 equals negative cosine squared. Take a second, think about why that works, write it out, do it for yourself. Ask me questions, write a note off to the side. Why'd you do that, Mr. Pike? Well, now I see that negative cosine squared is equal to sine squared minus 1, because that's sine squared minus 1. So I have cosine theta equals negative cosine squared, and then this is just negative cosine cubed theta. Happy day. Ooh, this one looks fun. I'm really excited about this one. Yay. Ooh, I'm jumping. Yay. Okay. I'm sorry, I just drank a lot of coffee. I'm really weird. Not that I'm not that weird anyways. Anyways, I'm adding fractions. Yay, I'm adding fractions. I need common denominators when I'm adding fractions. Yes, I do. So I need to multiply this one by 1 plus sine theta over 1 plus sine theta. Yay. And this one by cosine theta over cosine theta. Yay. So I have cosine squared theta plus, make sure you distribute everything to everything. So that is 1 plus sine theta plus sine squared theta. So this is 1 plus 2 sine theta plus sine squared theta, all over the same denominator, cosine theta times 1 plus sine theta. Sweet. Again, if you don't understand something, star it off to the side. Come ask me in class. Please, help yourselves. I can't help you until you help you, so help you. Okay, with this now, I see that I have cosine squared. I have plus sine squared. Cosine squared plus sine squared is 1 by the Pythagorean identity. So this is really 1 plus 2 sine theta. 1 plus 1 is 2. So I have 2 plus 2 sine theta all over cosine times 1 plus sine. Yay. Okay. Now, the top kind of looks like 1 plus sine theta, except they're both 2. So if I factor out a 2 from both of those terms, then this is 2 times 1 plus sine theta over cosine times 1 plus sine theta. Yay. 1 plus sine theta divided by 1 plus sine theta is 1. So I'm left with 2 over cosine theta, which is saying the same thing as 2 times 1 over cosine theta. So 2 would multiply to the top, right? Yeah. So this is just 2 secant theta. All right. Again, make sure you guys memorize the identities. If you do not memorize the identities, you will not pass this unit, and I will be sad because I told you, and I warned you, and I love you, and I want you to pass, so make sure you memorize the identities. All the identities. Oh, not just those. All the identities. Okay, you guys got to know this stuff. If you don't know this stuff, make sure you come ask me. I am here to help you, I promise. I promise, just as long as you guys take care of your own stuff. Take care of business, memorize, study, try it, don't give up, keep trying, always keep trying. Love you guys. Peace out. Bye-bye!